Alright, so I'm doing a short video on implementing a Lisp parser. So I'll probably have to record this in multiple parts because I don't have much time today. But I wanted to get this started. So I'm gonna implement a Lisp parser in C#. Why? Just because. And we'll see how I do. I don't really know all that much of Lisp, I should say. I know like the basic syntax is something like this, where you have like a parentheses followed by the operator which comes first. So this is like a function, and then it takes two arguments, 2, and then another list of things, which in this case is 7 times 3. So like the equivalent C# expression would be this. So the first step is going to be like implementing a general parser for parsing these expressions, and then I think there are some special constructs. Like you can define a variable x to have some value, let's say 2. I think that's the syntax. I'm already like struggling, right? But we'll look this up as we go. Yeah, this doesn't help. Examples. Yeah, so this is like definition of a function. There should also be definition of variables, no? It doesn't really matter. I'm just gonna stick with that. Sorry, I'm just gonna stick with that actually. So this would define like a variable x to have value 2, and this would be like available in a global scope then. So a line after that I could say, I don't know, like 2 plus x, which should equal 4. Yeah, oops. And then I also need to have a function syntax for defining functions. It's gonna be like this kind of thing. So here I need a list, right? So a list of arguments. Let's put that in another parentheses. And then that's going to be a function which takes x, y, and z as arguments, and then it computes something. So for example, it could compute, I don't know, like x plus y plus z. And actually in Lisp you can leave this out, so I don't have to like plus 2 times, I can just plus over the whole list. So that would be a function definition. And that would be a variable definition. Well, actually, wait, this needs a name, right? Well, no, it doesn't. Okay, no, so this is then like an anonymous function, essentially. So that'll give me a function, x, y, z, which I could apply immediately if I wanted. So the more complicated way to use this function would be something like wait. Oh yeah, so here I have a function, so this now is the value of the function. Oh, this is like the defined function. And then I apply the function to 1, 2, 3, and that should give back 6. So this is like a simple case, or the complicated case. And the simple case would be I take this function here, I define sum to have the value of this thing, which is a function, and that gives me that defines me the value sum. And so now I can type in a later piece of code, I can type this, right, which will also give 6. So I think that's approximately how Lisp works. If it isn't, I'm sorry. Then I'm sort of inventing like a messed up Lisp syntax, I guess. It doesn't really matter. I just wanted to like make some kind of parser to understand roughly how Lisp works. And then last thing is gonna be, I need an if and else statement, which is gonna be well, it needs a condition first. So if 1 is smaller than 2, and I can return 2 values here. So for example, I could return true or false, which is like the simplest, the stupidest if statement. So okay, so this is false. Wait, true. Yeah. And these of course can take like more like this could also be something else, right? I could put in 7 times 3 times 3 here, because Lisp is dynamically typed, so this doesn't like, there's no special typing stuff going on here. Right. Do I care about macros is the question. I don't really know how macros in Lisp work actually, because the point of writing this parser is, well, I was reading like a, I'm not sure what the blog post is called anymore. Yeah, I was reading this. Michael Nielsen is just, I don't know, like just a random guy. I've read some articles of him before. And so here he starts talking about Lisp and how it's very elegant and stuff. And I agree, like from what I know about Lisp, it's very elegant because it's based on the lambda calculus, and the lambda calculus is sort of a very fundamental way to represent computation. And he implemented his own Lisp parser, which is called Diddly Lisp. It's just like a very small Lisp implementation. And in the article, he just suggests to play around with it. And then at some point, oh yes, so here I'm using def instead of set, but it doesn't really matter. At some point, he starts saying that we will sort of look over the Diddly Lisp parser and see what it does within this article. But then I stopped reading actually, because I was like, I can make my own Diddly Lisp parser, right? Shouldn't be too hard, and I'm probably going to learn more by programming it myself instead of reading the article, which is about programming the parser, right? And actually, even I think he even mentions this at some point. Well, whatever. Okay, so let's get going because I don't have much time. I'm gonna split this up into parts. I also need string manipulation because later, if possible, I'm not sure yet if that's possible, I want to implement the Lisp parser I'm building here in C# in my own Lisp language, which I'm defining here, right? So I would like to bootstrap myself. So like essentially then I have a very simple compiler, which would be really cool. I'm not sure if that's possible, we will see, but I will need some sort of interaction. So let's say print just prints a value to a console, prints to console, and returns nil, which is Lisp's equivalent of null. So this is a function that just prints and doesn't return anything, or void, I should say, not null. I also need a read command, which probably just reads a whole line of text and returns user input, whatever has been read. Line of text, let's say. And then since these are like string functions, I need some simple string manipulation stuff. Actually, well, I certainly need like an index function. So let's say, what is indexing called in Lisp? Let's go actually with closure, because I'm maybe I may be debating learning closure in the future at some point. Array access. So I'll just use the same syntax they have, if I can find it quickly. Otherwise, I'm gonna. ChatGPT is faster for this, probably. a get. Really? Oh no, wait. Oh, nth. Okay, yeah, that's the one I meant. Yeah. Okay, so nth, my string should, and then 3 turns fourth char of string. I know what I mean by, yeah. Third. And then that should be enough, right? So I'm gonna say as a string, and so then I can just use equals and implement the rest as sort of a standard library, right? I don't need to modify strings. I'm not doing like any like variable reassignment. I think I'm just using, well, variable reassignment might be okay, but not. I'm not gonna like manipulate. I'm not gonna allow the user to change strings. You have to define a new string for that. So no mutable strings. This is enough. If I don't need loops, because loops can be implemented with recursion. We have functions, well, although if I need, maybe as macros, if I can figure out how macros work. I mean, I'm running into sort of a bootstrap problem here, right? Because I don't really know how Lisp works, and I'm trying to learn it by programming a parser for Lisp, which isn't like the best thing to do, maybe. It doesn't really matter. And that should be complete. So I'm gonna, in the last few minutes of this video, I'm just gonna start defining data structures for this. I can use the C# record feature, which is sort of new. So I'm gonna need I'm gonna probably stop commenting now, because it's gonna make me think less. Machine learning, pretty cool. Not sure if this is sound. Well, we will see. What the hell? It's so good. I don't even have to think anymore. Is that true though? Has a string name, certainly. Oh yeah, I forgot the name. No, wait, actually no, it doesn't have a name. It only takes a list of arguments, which is a string of args, or arg names I should say. And then I need a list of expressions. I mean, strictly speaking, these are whatever. I'm gonna call this root. It just gets confusing otherwise. And I'm gonna do a new thing called value, which inherits from root. And these are values. Oops. I don't think that's needed. It's a bit unclear to me how I implement addition, so I mean, this also needs like some sort of content, of course, but how do I... What? No, wait, this is the... Oh, here's the function definition. So wait, so it takes arguments. No, what am I doing? Okay, oh, I see my confusion now. Okay, so I was thinking about function as having... This is supposed to be the function definition, but then I also need a function application, which is this, for example, or also this, which was supposed to be my expression, but that doesn't, so I'm gonna call this apply. And that now takes a function and a list of arguments to which it is applied, right? So it takes, that's the function, that's the list of arguments, yes, okay. And the function though only has parameter names, that's up here. And what it does, which is what? That's an apply? I mean, this is an apply. Takes a function f, but is that a string or is that a, no, that's a function, that's not a string. Clearly. Okay, so apply takes a function f. Well, that's actually how I can do macros. Macros are kind of like apply given function name. Yeah, who knows? Expression. I mean, these are certainly. Is that just a root? I don't know. Let's just. I mean, oh yeah, actually it is a root. That makes sense. Yeah, because Lisp can just pass around anything, right? Okay, that's actually simpler than I thought. Yeah, I know. Param names. We have the arguments. Just this, the function application. Where do I store? Is that all? I almost feel like the definition of the function is missing, but I think I have it here, right? So that's the thing about Lisp, right? So Lisp, the data structure also, that I'm only defining like data structures that match what I've written down here essentially. So as long as I haven't forgotten anything down here, I should be fine. So function takes a list of parameters and then just comes a, oh wait, that's the part I was still editing. But then this is just a root. Function body. It's just a root node. I'm also gonna call this node, not root. Apply text to function. I think I'm good here. So it seems like almost seems like my like what the function does, like its semantic information is missing here. But in lambda calculus it's very simple, right? It's just function, and then you can apply functions, which is just like a string of expressions which are nodes in my case. And so this actually falls out completely, because that would just be, oh, I don't know, doesn't matter. And I'm gonna call this not a value but a primitive, because there are lots of values. So now I have int bool string, a function, and apply, and then I also need an if statement, which needs a, that's a bool now, right? That's certainly a bool condition, because that has to be executed. Wait a moment, does it have to be executed? Is that a, no, it's not a bool, because a bool is something that is already, no, a bool would be like true or false. But that's still a node which just returns a bool. Okay. Okay, then I need a node for the if branch and a node for the else branch, and I think I'm done. Oops. And then read and print. So print, oops, takes a value, and the read takes nothing. Read print, and the nth, no, actually it's a function, right? I can, does that have to be built in? It has to be built in, kind of, because that's array access, which is special. And I guess actually plus and times and all the operators all have to be built in. I'm not sure though. Do I just provide a built-in? I don't know. Built-in, that's like a special function which has a string name. So that's like plus. Oh, it gets hairy here. How do I represent this? So I have a built-in takes a function string name. List of parameter names. It's like, so the built-in function is like a definition of the. I'm gonna have to think about this more later, but it doesn't really matter right now. Apply. So this is like a. I need the plus, so the plus method has to be implemented somewhere, right? So it has to, I mean, I have it to use C# to calculate like the actual result of plus, and plus needs to be a built-in value or built-in function, because I can't just, yeah, I mean, I can't define plus any other way. I mean, there are like mathematical structures, but anyway, so plus is like kind of needed as a primitive. And so is built-in apply. Okay, whatever. I'm gonna stop it here. And I will see you in the next episode.